Well, hello everyone. This is KP the Math G. We're looking at another problem here. This is called the 2009 free response question number 1. I have probably two other I know I have three that I picked from this 2009 test. And I realize as we think about this that we have another velocity thing. Okay, we got just another velocity problem, but I think sometimes there is a slight little twist in some of the questions, just a slight little twist, and that's the reason why I picked this one. It's a very good problem, and I want to say A, B. I could easily quickly do C. That wouldn't take too long to do that. Probably the whole thing. But I'm not sure how long. I might can get through with it within one session here. So I'm going to try my best to do one session, but I have to kind of monitor how long I take, because this old camera it only allows me at best 32 minutes. I don't know why, but maybe that's the key word. It's old. Okay. I'm not old yet. I'm getting there, but I'm not old yet. But anyway, okay, putting all bad jokes aside, let's get started. As you can tell, I don't have everything. If you can look here, this is velocity with respect to time. This is, of course, time. This is in minutes, 1 through 12, well, 0 through 12, actually, minutes here. And so we have graph going here, and then below here, and then nothing happening here, and then up above here, and so on until it comes down to here. All right, and I know that a lot of this is going to be overlapping. As a matter of fact, you go, as I said before, you get into another year, you're going to find another velocity. It may be 2011, but you'll see another velocity equation, and I hope maybe you get one of these, because this could be one of the easier questions that you get if you kind of get familiar. And again, I think a while back I did something on the difference between total distance and net distance, and we're going to get into those two as well in our discussion. It says, the first one says, find the acceleration, and it's talking about this girl named Carla rides her bike along a straight road from home to school, starting at home at t equals 0 minutes and arriving at school at time t equals 12 minutes. During this time interval, her velocity v at t in miles per minute is modeled by the piecewise linear function whose graph is shown here. Now, A part says, find the acceleration of Caren, and they don't spell that with a K. It's a C. Caren's bicycle at 7.5 minutes. She is a calculus student. Who would guess that? All right. 7.5 minutes. All right, so acceleration. If this is the velocity piecewise function, then acceleration, how do we find that? Think about what you're finding. We're finding acceleration. So if we want acceleration, we know that v prime at t, all right, that's right, v prime at t is equal to a at t. So I'm looking for the slope. I'm looking for 7.5 somewhere right in here. All right, so 7.5 is here, and I'm looking at this slope. Since we're looking at the slope of the tangent line to the curve or whatever, we're looking at that slope there. Well, this point happens to be 7 comma 0.3. So there's one point that's 0 comma 7, 7 comma 0.3. Alright, and then the other one is 8 comma 0.2. Alright, I got the points. You might say that V at 7, if you want to say that, is 0.3, and V at 8 is equal to 0.2. Same idea. Alright, same exact thing we're looking at. I don't have much room to write, so I'm going to erase and erase. I've got to keep this on this side if I can. So we're going to try to put our answer right down here. So let's find that slope. I just wrote it down, didn't I? Oh my, I'm sorry. 7 comma 0.3, 8 comma 0.2. Now this is slope, so 0.3 minus 0.2, or we can do 0.2 minus 0.3. It doesn't matter which one you do, but you got to stay in the same direction. So 2 going in this direction here, so I need to go in this direction here. Alright, so 8 minus 7, we know that that's 1. We know that that's 0.1. So, and of course, 0.1, we got to get the correct unit. So, if the units for velocity is minutes, now let's see, I'm trying to think how far that is. Miles, I think it is. Trying to think of the, let's see, yeah, okay, miles per minute, yes. So if this is miles per minute, this is in miles per minute, which we say minute squared, okay? Alright, like that. Miles per minute squared. I want to say that will give you 2 points right there, right off the bat. Okay, you had to get, and it's negative. Wow! Yes, it is negative. Bet you could shout through the camera if you could. KP, it's negative. Okay, now I lost the point, but I got the units correctly. Okay, well, anyway. Alright, so that, yeah, I had to remember. 0.2 minus 0.3 is negative 0.1, right? At this level, we should know that. Okay, anyhow. Alright. Alright, don't lose a point like I just did. Alright, now, that's the simple one. Of course, that would be a simple one. Alright, they are saying interpret this meaning here. So B is interpret. The meaning of, let's see, from 0 to 12, absolute value bars. There is a huge difference between the absolute value bars and not having them. Well, this is the total distance. When we deal with an integral of v to t, we're dealing with distance, but this absolute value bar says it's the total distance. So this represents the total distance Caren traveled. Alright, I think it's 1L, but anyway, who cares? Oh, okay, alright, traveled. As it LLED, you can comment on that and say, KP, it's LLED, but hey, total distance traveled. Okay, So that's really what that is. It's totaled it. In other words, we don't say this plus this equals 0. We treat this as the absolute value. Everything is positive. And now we count this and this and this and this and this, whatever. Okay, now this is what we count. And we're making this, the absolute value is making this positive, so we have to add that as well. So that's what we have here. And it says find the value. Okay, so let's do that. Okay, and I did all of the above here, so let me see what I got. Alright, okay, this is 2 units. This is a triangle. Alright, so we're saying, let's see, this is 2 times 0.2 divided by 2, and this is the same thing. They're the exact same triangle. The base times the height. Remember, area of a triangle is divided by 2. Don't forget that. We don't have this here, but we are talking about. And if you want to, you can say, well, I don't want to. You can say from 0 to 2, b at t dt, or you can even say from 0 to 4. However, how you want to do that is equal to 0. Or 2. Okay, so 2 times 0.2 over 2. From 2 to 4, same thing, v at t dt is equal to 2 times 0.02. What is wrong with me today? Okay, over 2, and keep going and keep going. Alright, like that, and you're going to add all that stuff up, see? Alright, so from 2 to 4, alright. The next one would be from 4. I'm not going to recopy or copy this down every time. So from 4, we can even go from, there's nothing here from 4 to 5. If you want to do that, you can. 0. Well, and then you can say from 5 to 7. I like to just say from 4 to 7. Okay, so actually we're looking at this trapezoid. So let's see, the 2 parallel lines, that's the 2 bases. That's 2 on the bottom. At the top, that's 1. So 2 plus 1. Remember, on trapezoids, you add the 2 parallel parts, and then you multiply that by the height, which is 0.3. So 0.3, and then we're going to divide that by 2. Remember, trapezoids are divided by 2 as well. This is another trapezoid, except this time the parallel parts are this way. So we have on this one, let's say 0.3 plus 0.2 times the height, which is really in this case only 1. Got to be careful with that. Okay, it's this way now. This is still a trapezoid, but it's turned this way. Okay, and then that one's divided by 2. And then we've got one more. If you want to say from 4 to 7, this would be from 7 to 8. Now from 8 to, and if you want to divide it up even more, where it's not a trapezoid, in other words, you could do a triangle here or rectangle here, and you'd have to make this a trapezoid here. Okay, a triangle here, a rectangle here, and if you want to make a triangle there and then a rectangle there, you could, but a lot of work. Alright, so now we got that one's from 7 to 8 right there. So from 8 to 12, That's a trapezoid too. 9, 10, 11, 12. So 9, 10, 11, 12 is 4. 9, 10, 11, 12. 4 plus, how much is this one? 9, 10, 11 plus 3. The height is 0.2. Now divided by 2. And when we add all of these up, we have to sum them all up. Okay. Then we're going to come up with an answer of, and by the way, this is just really, if you just look at this, this is 0.2, that divides out, this is 0.2. You gotta remember, we're not subtracting this off because we're taking the absolute value of it. Do not put a minus sign here. This is 3 over 2. Oh, this is point of 3 times 3. 0.3 times 3 is 0.9. So 0.9 over 2. 0.5 over 2 here. So 0.3 plus 0.2 is 0.5. This is going to be 7 times 2 is 1.4 over 2. Alright, when we add all those up, we get 1.8. Now that is called total distance. Even though this one's down, the absolute value brings it up, and that's what you got to count for. This is total distance, okay? And that's what we just talked about a while ago. Very important to know the difference between this, okay? Erase some of this, it's starting to overlap a little bit. The difference between this and this are not necessarily the same. We will look at this one later. We looked at this one right now. Okay. This is total, this is displacement, okay, or net distance here. Okay. Alright, let's look at the next. Let's go ahead and do the C part. Alright, 1.8 miles. Okay. Excuse me. Okay. Erase stuff up here. I don't like to be holding on to that. Now, anytime you deal with distance, you got to remember you're dealing with area under the curve. This area means the area of velocity is distance. If this were acceleration, the area of acceleration would be velocity. Okay? Alright. Now, let's leave this little area open here. And it says that C part, the C question is, shortly after leaving home, Caren realizes she left her calculus homework at home and she returns to get it. At what time does she turn around and go back home? Give a reason for your answer. Which is the most obvious that you would think, even intuitively, what would you think would be the time t that she says, oh, I forgot my book, and she returns home to get it? Yeah, right there. That t equals 2. So C part at t equals 2. She returns home to get her book. And I'm abbreviating, I know, because signs change from positive to negative at t equals 2. Okay. Alright. This is when the velocity is, you remember that if something is going to the right, then at this point it's going back to the left, isn't it? Okay, it's below the below the t-axis, so this means that she's turning around right here. Okay, and so that would be C part. Alright, and I will read to you what, let me pick this up. Okay. Their answer is the same as what I'm saying to you. Caren turns around to go back at time t equals 2 minutes. This is the time at which her velocity changes from positive to negative. So you might want to say her velocity changes. Alright. I believe you could get away with the signs changing, but her velocity changes from positive to negative. Okay. You can have a negative velocity, you know that, right? Yeah, okay. Okay, there it is. Okay, let's look at another final question, part D. Now we run into a problem. I might need to flip the board over. Now, Caren, let's go ahead, because of the question, I already know the nature of the question. Let's go ahead and really figure out how far Caren is from home. Okay? Now, we're looking at Caren's distance. Caren, how do you spell Caren? E-N. Caren's distance. And that's called the net distance now. Net distance from home. Okay, so now we're not looking at, that's okay, 1.8 is not how far she went. Okay, that's not how far it is from her home, because she's getting, this is the exact same area as this area is, right? She's going back home. So really you're counting from 4 excuse me excuse me maybe even from 5 to 12, because these cancel each other out. So remember, this area, by the way, remember this area is now, well, it was 2 times 0.2 divided by 2. This is 0.2 right here. Alright, but this is a negative 0.2. Now we take the negative, yeah, see, okay. So we are looking at it from 0 to 12. We've got to make this negative, because we are not looking at total distance. It's not an absolute value. This is what we're looking at here. We're looking at this here now. Ladies and gentlemen, this is what we're looking at. Okay, this is 0 here. Well, there's 0 here. Alright, so V at T dt is equal to. Alright, now this one was 2.1, or 2 plus 1 over 2, which is, that was equal to 0.9 over 2, because remember this is times, so this is 0.3 times 3, 2 plus 1 is 3 over 2, so this is 0.9 over 2 plus, if you want to say 0, if you want to put these down you can, but this is okay to say this. Alright, so this was I want to say this is 0.3 plus, I don't know why I put that in parentheses. Alright, 0.3 plus 0.2 over 2 times, okay, yeah, the height is 0.3. Let's see, hold on. Where am I at now? Okay, that's this one here. Alright, 0.3 plus 0.2 times 1, yeah, times 1. So that's really 0.5. 0.3, 0.2 is 0.5. 0.5 over 2, like that. Okay, plus. Now let's get the rest of this here. And I wish now I kept up with that. 1, 2, 3, 4. 4 plus 1, 2, 3. Alright, the height is 0.2. Always trapezoids are divided by 2. So that's it. Let's see. Alright, we're looking at Caren's net distance. So this is 0.9 over 2, 0.5. That's 9 plus 5 is 14, so 1.4 over 2, like that. This is 7. Alright, 7 times 0.2. That's 1.4. Over 2, like that. So this is 2.8 over 2, which is really 1.4 miles. Now that's her net distance. Now remember, it was 1.8. If you take these two away, the easiest way to do is, if you remember that the total was 1.8, then you can take away 0.02 minus this. This is going to, remember we added these two up. So now we got to take these two away. And our kitty cat can't decide whether to learn any calculus or not. It keeps coming in my room here. Okay, so she decided she didn't want any calculus. Okay, alright. Alright, so that's what you can do. If you remembered that the total time was 1.8, then all you got to do is subtract off these two right here. Okay, 1.4 miles. So that's Caren's distance from her home to school. That's her net. That's the net distance. That's important to know how to do that. But then we come with one named Larry. Now Larry, let's turn this over since we're not using this table anymore. Let's put up here Caren's distance. Alright, so Caren lives 1.4 miles from school. Okay. Lives. Okay. Alright. I don't want any English teachers to get upset with me here. Larry's is modeled by his velocity equation is WT is equal to pi over 15 sine of pi over 12 t. That's the velocity. So remember, if we want to find distance, we are going to have to do this, aren't we? So to get distance, I want that. So that means we have to, I'm going to put the pi over 15 on the outside. Alright, from 0 to 12. Alright, sine pi over 12 t, like that, dt, like that, okay? And you will get an answer if you, I think you can use your calculator on this. But I'm going to do it by hand. I hope I have enough time to do that. Oh, maybe not. I'm not sure. But just so we know, this equals exactly equal to 1.6 miles. And the question is, and in case we don't get through, at least you know that it is 1.6 miles. The question was, so Larry, let's just write this down first. Larry lives 1.6 miles from school. So the question is, who lives the closest? So Caren lives. Oh my goodness, I need room to do this calculus problem, don't I? All right, so Caren lives closer. You don't even have to say how much closer, okay? Just say closer to school. You have shown the work. This is it right here. Okay, so very quickly, the derivative of, I know, okay, so let u be equal to pi over 12 t. du very quickly is pi over 12 dt. So if I multiply by 12 over pi, then all of this divides out, and 12 over pi du. Okay, so 12 over pi, what am I doing? Pi